In this lesson, we're going to go over a couple of problems, one of which utilizes the rationalization of the numerator. In Algebra 2, many times you would have to simplify the denominator by taking the conjugate, and you would usually either have an imaginary thing here or a radical like what we have here. This time it's a little bit different. We have the radical in the numerator. But notice that x is approaching 3, so if you put 3 in right now, although they would work in both the numerator and denominator separately as expressions, the 3 would make the whole thing undefined. So we need to see if by rationalizing the numerator we will be able to simplify out the x minus 3. So just like when you used to do a denominator in Algebra 2, you would find the conjugate of the square root of x plus 1 then minus 2, which is the square root of x plus 1 plus 2. And you have to multiply both the numerator and the denominator by that value. Once you do that, I would suggest leaving the denominator factored out. But the numerator, you will have to go through and multiply it out. Square root of x plus 1 times square root of x plus 1 is simply x plus 1. But the nice thing about conjugates is when you do the inner and outer terms, if you want to use FOIL comparison, they simplify out. So you're left with negative 2 times 2 is negative 4. Keep in mind, you're not technically just multiplying the first terms and the last terms. You are using the distributive property. It's just that the two middle ones simplify to 0, so it's gone. Well, if you notice, 1 plus negative 4 is negative 3, and in a lot of these textbook type problems when they're showing this method, this has to occur. And in the real world, it could be very possible that this could be x minus 2, and then it's x minus 3 here, so you still have that issue, which would mean that it is probably an unbounded type of function, so it'd be undefined. So these would mark out, and you'd be left with 1 over the square root of x plus 1, then plus 2. Now, if you put the 3 in here, 3 plus 1 is 4, square root of 4 is 2. You add the 2's together, and you should get 1/4. So this is another one of those situations. If you happen to graph this expression, change it to y equals in your graphing calculator, and you graph this expression, they would be the same except for at that one point. But since the limit of this exists, and as a number 1/4, that means this has to have the same limit. So much like the dividing out technique. My other example is not a rationalizing the numerator. It actually falls into the category of the previous technique, dividing out, but I decided to place this with the rationalization so you'd have a little practice with it before we go through it. This is the whole problem, but let's look at it from the beginning. The reason why I'm saying it could be a dividing out is because notice all you have left is an x, but what makes this unique from the ones we've done previously is that you have a complex fraction. So you're going to have to take those two fractions in the numerator and combine them, which requires you to get a common denominator. And when you have expressions like x plus 4 and 4, then the easiest thing to do is to simply, since this is x plus 4, you need a 4, so let's multiply both the numerator and denominator by that 4. And here, since you need the x plus 4, multiply the numerator and the denominator by the x plus 4. Sometimes when this is real complicated, what I would do, especially on an AP exam, if it's this type of thing, I would put this expression over to the side and then say equals and solve it separately. But there's not much more to write, so I decided to leave it in the limit right now. And realize the goal is to get an x in the numerator that we can take out with that denominator x. So we multiply. Notice the denominators I leave factored. And do not fall into the trap that some people do in Algebra 2 where they mark these out. That just brings you back to this. You're doing this is unsimplified, but you're doing this so that you can put these two together because now they have the same denominator. And I've left the x on the bottom alone. So I put them together, and I get the following. It's 4 minus x. And then notice this would be minus 4. So 4 minus 4, you are left with negative x. You still have this 4 over x plus 2, and then the x at the bottom. Haven't marked anything out, so all of these expressions are equivalent throughout the whole function. Since this is a division problem, what I can now do is change it to its equivalent multiplication problem by multiplying by its multiplicative inverse, which is 1 over x. And notice what you can do. Since this is negative x and this is x, you can simplify those out, and you are left with a negative 1 in the numerator. In the denominator, you now have 4 times x plus 4. When you made this move, this is actually a function that agrees with all the points except for at 0. But because of what we know about limits, if they're equivalent all but one point, as long as this one will reach a limit that exists and is a value, it will be the same for the previous one. So if you place 0 in here, you would get 0 plus 4 is 4. 4 times 4 is 16. So you get negative 1/16.